Hi everyone. So welcome to the section on asynchronous programming in a Dart. So throughout this whole section we'll see how we can use parallelism in a Dart, how you can create different kinds of threads in a Dart. So threads is in the sense that Dart has another kind of mechanism like a isolate. How to use this async keyword and the future object. So in this video first we'll discuss about the future object. Okay, so first Dart is a single threaded programming language. So let's say if you are performing some sort of task. So if suppose the one task is following to some other task. So if any of the task is like blocking in nature, or if it is, let's say, the time consuming in nature, the rest of the instruction will not get executed. So this type of programming generally we call it as a synchronous programming. So I would call it as a synchronous programming. So I will write first a very simple and small code related to synchronous programming, and then we'll see how we can make it asynchronous. Let's take one more example. So let's say you have a web server application, and web server is hitting by, let's say, thousands of users at the same time. So it should not happen that if web server is serving the request for one user till the second user cannot request anything, till it is serving for one user, the other should also request and other should also get response. It may happen that the other will get a request sooner than the first one which is already been requested. So every single request should be independent of every other request. So that is the idea behind asynchronous program. Now how to implement this asynchronous programming we'll see with the help of this future object in this video. So let's first implement a very simple blocking based IO, one small simple code. Let's say I'm just asking for your name, and I'll just print that particular name as output. Second, I will use this stdin and read line sync, and I'll grab it into name variable. Now this is completely synchronous in nature. So, and let's just print your name is this. So unless and until you do not provide input from your console, it won't execute this part of instruction. So that is called as a synchronous programming, and that is how it is blocking our rest of the code from the execution. So let's say I'll give like a Ankit, and it will print me your name is Ankit. So unless and until I do not provide this Ankit as a input name and press the enter, the rest of the part of code will not get executed. So that is the synchronous way. But in a real world application, we need a kind of asynchronous programming. So till we are serving for one particular function, we don't want that other function also do not get executed. They'll also run in a parallelly. So let me just comment this part. Now we'll write with the help of this future object one kind of asynchronous programming in a Dart. Okay, so let's take another example which will return this future object. So future idea behind this future object is if something you are going to get in a future. So let's say you give some task to one particular module of your code or some particular function of your code. So somewhere in the future it will return the output. But till that time, what will you do? Till that time you execute rest of the instruction of your code. If possible, that the output of returned by this future object is not going to get used by your rest of the code. Okay, so let me create one file first of all. So I have already inside this F drive test dart.txt. Let me write some more statement. Let's say hi, bye. Okay, and we are going to read this particular file. So let me create one file object first of all. Okay, now I'll read as a string sync, or I can read as a string. So now if you see the difference, that read as a string sync will return me the string. So in a synchronous way it will read the file. So till the execution of this file will not get completed, the rest of the execution of your whole main application will not proceed. Whereas if you use this particular another function like a read as a string, it will return the future object. So let's just first use this particular function, and I will just grab the data in this data hold the content of file into data variable and will print. Okay, and at the end another statement I'll write like a end of, let's say, program. So everything is sequential in nature here. Let's just run and see. So now if you see the execution of your code, first it has read the line, it has grabbed the data from that particular line into data variable, and it has printed all those data as per this line, and at the end of the program. But during this reading of code, it has to wait for some time. Now why this CPU is unused during that particular time? That's where the asynchronous programming will come into picture. Because during this ideal time of CPU, it can execute the rest of the part of instruction. Now how? So those things we'll see now. Now let me just comment this part, and I'll share all the node code with you. And let's just select the same code. Now instead of read as a string sync, we are going to use read string, and here now we'll get the future object. So let me give name here, let's say file data. Now this future object is a part of this data async library, so it is giving me suggestion to import this dart : async module. So I imported this dart async module. Okay, now we cannot print the data like this because we are going completely asynchronous way. Now it has started reading this particular file. Now somewhere in a future time we'll get the output that it has read this file, take this data. Okay, so we are going to use this file data.then function. Now what this then function will do, whatever this future objects, any of the function written in this Dart programming language, you can apply this then function. So whenever some function will return a future, you can apply this then function and you can grab the return value output returned by this particular part in a future. So whenever something will return in a future, you will grab inside this particular part. Okay, so let's grab it in terms of, let's say, data, and as soon as the data will arrive, we'll just print it. Okay, so I can just print simply like this particular data. Okay, now let me just run and we'll see how execution will go in. So now you can see the first it has printed the end of the program. Now why? Because all the process is completely asynchronous in nature. So it has started reading this particular file. It has given this task to this particular function, and it has told that whenever you read this data into this particular future object, inform me. So till that time the execution of this part has completely halted, but now CPU is idle, so CPU is thinking that I should execute rest of the instruction. So it has printed this particular instruction. Now whenever in a future time or in future somewhere it has got the data or it has executed the function. So whatever the return by this particular function, it has grabbed inside this then method. So whenever this particular future object, so any future object you can apply this then method. So whenever this future object work has been finished, you can grab the output inside this particular variable, and we have just printed this particular variable. Okay, so that is all about how to do asynchronous programming with the help of this future object. So whenever any function will return by this return the future object, you can grab this output with the help of this then method, you can apply on the top of it. Okay, so that is all about the future object. In the next video we'll see about the async, and then we'll see about the isolate. So that's all about this video. See you in the next video.